Thank you, ladies and gentlemen. This is our first session for our Keynote speeches. I'm pleased to co-chair with Professor Jill Clausen from Technical University of Denmark. I made myself the first chairman. Simply like to let you know, actually, the basic idea of the Keynote sessions and this 20 speakers really spent time in the last year or so for this, give you a status of the work and also the futures for young and I realize many not so young colleagues also. They give, after this talk, they all will prepare a review paper which will be published, considered to be published as a special issue in The Air. Our chief editor is there, Professor Bill Nazaroff, kindly agree and support this program. It was Bill, me, and Yingxin, we worked together, developed this program, and look forward for the 10-hour sessions. Yes, Jill, please.
Okay, it's a great pleasure for me to introduce our first speaker in this series, and that is Dr. Yingxin, who is a professor at Tsinghua University in Beijing. And she's presently the Vice Dean of the School of Architecture and head of the Department of Building Science. So the title of her presentation is Dynamic Thermal Environment and Thermal Comfort. Please. Yes. Let's do
it. Ladies and gentlemen, can you hear me? It works. The mic works? Okay. It's too high, I think. That works. Yes, okay. Good morning. Today I will give the first keynote lecture. My topic is dynamic thermal environment and thermal comfort. I think everyone working on thermal comfort has, in fact, we're facing to a problem as the keep balance between thermal comfort and energy consumption, because the most part of energy consumption is the cost for keep good thermal comfort. So our question always is it possible to achieve thermal comfort while not increasing much building energy? This topic is about dynamic thermal environment.
Yeah, it is good.
Oh, I'm sorry. This one is the old version, not the new version. This is a PowerPoint file. Sorry. Change to the new version of PPT file, because just now I just upload. This one is the old version.呢個係頭先我啱先 upload 一個新嘅。
You have a USB.
No. Is that the new one?
This is the right one. Okay. Just on my topic, you can remember that my topic is about dynamic thermal comfort. Why we talk about dynamic thermal environment? Because in fact, all we use, the standard we use is for stable environment. But the stable environment is not exist in the natural environment. It's an artificial one. We can only create a stable environment in climate chamber. What is a stable environment means every parameter variation very small, so that the human body cannot perceive. The second one, as a stable environment, will consume more energy. But are you sure it is really comfortable and really healthy? Let's look at the current standards in the world. No matter, here shows ISO and ASHRAE standard, European standard, also include Chinese standard. All the current standards for air conditioning building, thermal comfort for air conditioning building, are based on PMV. PMV is derived from the stable thermal environment created in climate chamber. So the comfortable range is quite limited. For example, in ISO 7730, the smaller variation, the better thermal environment according to this ISO standard. The problem is it this one, the really? Oh, is it the really best? But this is a question. But anyway, this one, the highest class thermal environment will consume more energy. This can have been confirmed. So we have done some epidemiological investigation on SBS and air conditioning usage. This field survey has been done in 2000 and 2001, although this just published recently. And now it's more difficult to do this kind of investigation because less and less people, more people use air conditioning. Less and less people not use air conditioning. This survey is in investigation area is in Jiangsu and Shanghai, east part of China, most developed place in China. We sorted the people in four groups. Both family and office use air conditioning. Only office or only family home use air conditioning. Both don't use air conditioning. And the investigate discomfortable symptom include 12 typical one, 11 typical one, and the last one is other discomfort. What is the result? The result, we compare group A, use both air conditioning, compare D is the group no air conditioning, both home and the workplace has no air conditioning. So other three groups compared to group D, we all show that they has a higher risk to suffering from discomfort because the OR value is higher than 1. So we found that the SBS is strongly related to air conditioning usage. But most people believe that SBS caused by bad air quality. Very few people think it's related to temperature. Is it because in the air conditioning environment, the temperature is different from outside? We should consider if the temperature has some problem or not. So we do a more exact experiment on climate chamber for the to study the long time staying in stable environment. Is it healthy or unhealthy? We use 2 group students as a subject, young person, male people, natural ventilation group or air conditioning group. Natural ventilation group, it means they are both working place or residents have no air conditioning, or they just under the air conditioning environment less than 2 hours per day. And another group is both working place and home and even transportation have air conditioning. It's almost 24 hours under air conditioning environment. And the experiment is in 2 chambers. One chamber 26 centigrade, another one 30 centigrade. Each chamber for 1 hour. First a neutral environment, then to high temperature environment, each for 1 hour. Between the experiment, between this staying 2 hours, there are many physical tests, include blood sampling. This is the result. We show that in the 36 centigrade environment, high temperature, air conditioning group shows worse thermal sensation. They vote higher than natural ventilation group. They are bad thermal comfort vote. And the skin temperature increased slowly, not response slowly. And the chest feet temperature difference higher, means there has worse regulation, thermal regulation. And the sweating value, this one, the empty triangle is natural ventilation one, and this black one is air conditioning group. It's a pity that in the normal group, the more natural ventilation person, and the thin and a little bit fat group, the overweighted, they are all air conditioning group. But anyway, the average sweating value of a natural group, ventilation group is higher, and heart rate variation of air conditioning group also very high, show the higher pressure, higher stress. And this one is most important from blood sampling, is a heat stress protein, which it showed the natural ventilation group has much higher value than the air conditioning group. That means the higher HSP 70 shows stronger thermal adaptability. That means air conditioning group's thermal regulation ability has declined because they are staying in the stable environment for too long time. This is a publication. And so I would like to give a small summary that a stable thermal environment may lead to degeneration of the people's inherent ability of combating thermal stress, and hence weaken people's thermal adaptability. The second point is the dynamic thermal environment is ubiquitous. If the thermal parameters vary, such as temperature, velocity, relative humidity, radiation, if they varies, that means it's a dynamic thermal environment. And for example, the natural ventilation, oscillating fan, and transient space, and dynamic air conditioning, they are all dynamic thermal environment. So the problem is how to evaluate it, and what kind of dynamic environment is more comfortable. So the second question is, what is the comfortable dynamic thermal environment? We all find that, all people find that in the free-running building, the people, or nature ventilated building, the people have wider comfort range. Just like showing in the adaptive model. That's very different from PMV. This is why. What is the reason? We can give three kinds of explanations. The first one is the physical factors. For example, just an example, air velocity variation and the air velocity spectrum. That's maybe the most important physical factor. And the second one is a higher turbulence intensity of the air velocity may increase the Nusselt number and then increase the convection heat loss from people's skin, so make people cooler in the warm environment. About the physiological adaptation, I just mentioned, the people who staying in the long time in the air conditioning environment, they will decline their ability against the high temperature. That means a kind of physiological adaptation. The third one, psychological adaptation. Some literature shows that the perceived control or if the people have, occupants has more options, they will have a higher adaptability. So first to see the physical parameters. This one is air flows. We found that this is a typical time series of a natural wind, this is a mechanical wind, and this one is a buoyant flow. We found that a natural wind has a property of a non-symmetric to the average line, but this one is quite symmetric to the average line. And this one is a stochastic variation, and this one is a non-linear, non-period, like a chaos variation. And this one, turbulent intensity is lower, but this one, turbulent intensity is higher. We also find the buoyancy flow force as a chimney effect, because the buoyancy flow is just between these two. And about logarithmic power spectrum, we can show that it can show that the natural wind, the exponent value is higher than 1.2, and the mechanical wind is just between 0 and 1. The typical one is 0. And the slope of a buoyant flow is close to 1. So according to this analysis, the difference between mechanical wind and natural wind, we developed a dynamic air generator. This kind of generator includes the fans and the diffusers. The picture shows a kind of fan. It's controlled by motor. The motor we can use through computer to input the signal to control the motor, and the generated constant airflow like this, the simulated natural wind like this, and the sinusoidal airflow like this. We compare it, the three kinds of airflow by the generator. We found that in the experiment is under, the velocity is fixed, and the temperature is a high temperature and neutral temperature. We found that in the neutral temperature, most people choose constant flow. The second rate is simulated natural wind. The people don't like sinusoidal airflow. But in the high temperature, most people chose imitating natural wind. Now, very few people choose constant flow. About the draft volt, we found that in the high temperature environment, most people think draft of the simulated natural wind is lowest. But in the neutral environment, they are not very different. So in this case, we also found that we can use natural wind to increase the air velocity, so we can increase the neutral temperature for air conditioning environment, increase to 30 centigrade. The people also feel neutral. And how about the performance? People may think the dynamic airflow may be make you more cool in the more comfortable in the warm environment, but maybe it will decrease the occupant's performance. We do the experiment. Several students, PhD students, do the repeated experiment. We found that we use three kinds of airflow: constant mechanical wind, simulated natural wind, and no airflow. Of course, the temperature difference. The color here shows the different kind of wind. And this experiment is most people vote neutral, and here is people vote slightly warm. But you can find that no matter memory typing, addition, and pattern matching, no matter what kind of task, their performance not very different. Of course, there are some different, but the difference not very significant. So anyway, we can say in just a temperature difference like this, increase some temperature and use a wind velocity variation will not decrease the performance. And so about the airflow, we still have some quite a lot of questions to be answered. For example, how to describe and acquired the most pleasant natural wind, for example, breeze. How to describe breeze? And the better tactile sensation may be the reason of less draft. People feel natural wind softer. And can tactile sensation of different airflow be described quantitatively? I don't know. And is the direction fluctuation of natural wind the key factor impacting thermal comfort as well as velocity fluctuation? Maybe, but more difficult to study, to research in it. The third about climate adaptation. People, maybe in the past we would think that the free-running building we have adaptation, but finally, in fact, we found that even in heating and air conditioning environment, we also have the climate adaptation. This one is an experiment about heating and not heating area. In the north part of China, there's a traditional heating space region. We use a district heating system. And in the south part of China, there are no district heating system. People only use individual heating facilities. So they used to keep the room temperature quite low, around the 10 centigrade, although outdoor temperature is much higher than north part of China. North part of China, the heating indoor temperature in winter is quite high. So we chose a student, not student, as a subject from Beijing and Shanghai. We separately to do climate chamber experiment in Shanghai and in Beijing to choose a native person. And the subject is a young person, a male person. To do the experiment cases from 20 centigrade to 12 centigrade, quite low temperature. They are close to the same. But the result shows the TSV vote. It's a Shanghai group, that's Beijing group, and PMV. We found that here, the Beijing group felt cooler in the same temperature, indoor temperature. Beijing group felt more uncomfortable. And about neutral temperature, acceptable temperature, or this acceptable temperature as the temperature difference as a 2.5 centigrade acceptable, 85% acceptance. As a Shanghai group, accepted temperature is lower, really lower than Beijing. And the skin temperature decrease in Shanghai group, and they are going into the low temperature, decrease very fast, but in Beijing group, decrease slowly. And also they feel shiver. Beijing group show higher shiver, Shanghai group not so high shiver. Even in a 12 centigrade, Beijing groups, some subjects escape from the chambers. They said, I cannot sit here. I cannot, too hard to me. But Shanghai group is okay, no problem. So Shanghai group had a stronger physiological adaptation to the cold indoor environment. So the experience in the indoor environment also is very strong factor to thermal adaptation. And about outdoor temperature effect, this one is an on-site field survey in winter in Beijing. We found that this line, black line, is PMV, and this one is the real volt at TSV. We found that if the temperature, indoor temperature, is lower than neutral, the people's volt are always higher than in the. This one is not a climate chamber; it's on-site investigation. They always vote higher than PMV. If the outdoor temperature indoor temperature is higher than neutral, they also vote higher. When the outdoor temperature is lower, indoor they vote higher. Outdoor temperature higher, they vote lower. So outdoor temperature, no matter if the indoor temperature is the same, but the outdoor temperature also affect people real feeling. It's very strange. And we do the climate chamber experiment, very strict control. There's a kind of cross experiment.
5 minutes, please.
Okay. This one outdoor daily average temperature, and this one is indoor temperature is higher, lower, close changed. But we found that although the indoor temperature the same, outdoor temperature higher, the volt lower, the same temperature we can find. Okay, the final problem is, what is a mechanism of a psychological thermal adaptation? We do the on-site investigation for central control and individual control for heating. The central control heating, the occupants have no chance to control by themselves. Although their temperature, indoor temperature as a central system is higher, in individual control is lower, but the volt is different. In the same temperature, individual control, the volt always higher than district heating system. And the close resistant occupants for the individual control, they change more. But this one is compare the same, change it to the close the same. So the result shows occupants use a household gas boiler. Individual control has higher thermal sensation at same temperature, high acceptance, and better thermal comfort, and lower neutral temperature, saving and less energy consumption. And another field survey in Shanghai, in Beijing for heating, showed a similar result with and without individual control, and with without heating. This shows that this one is the same as the former one, and this one shows the with heating, no matter they use or not, the feeling is better. So this on-site investigation, finally we showed the chamber experiment about cooling or not. The chamber experiment put the subject into the chamber. The temperature increase. And one experiment, we call them the no cooling in room. Another one shows, tell the subject that they are cooling at room, and you can vote. And another group, they're cooling. If you use cooling there, you have to pay. The result shows no cooling, people, the same temperature, people vote higher. With cooling, the people vote lower. For the paid air conditioning, little bit higher than the free charge air conditioning. So this shows that if the people have no ability to control the environment, they will be anxious. So they will worsen their sensation for cooling sensation. So the change, the difference is about 0.2 to 0.5. So perceived control is so important. That's the conclusion. To my all presentation is creating stable indoor thermal environment could not be our ultimate goal for built environment. And dynamic thermal environment with some natural feature may be consistent more to the natural attribute of a human body. So it can keep people's adaptability. And the mechanism of a human thermal adaptation has been discovered step by step. Then we have to do more in the future. Perceived control plays an important role in psychological adaptation. So the further study is here. What is the mechanism of dynamic thermal comfort? What is the most appropriate thermal environment for both comfort and healthy? How to build such kind of thermal environment? How to evaluate the dynamic thermal environment? How to evaluate mixed mode indoor environment, nature, ventilated, and plus air conditioning? Because now our evaluation model is separate, air conditioning and free running building. So steady thermal environment has been well understood, and the dynamic thermal environment will be our next further goal. Thank you.
Thank you very much, Professor Su, for this interesting presentation. I would like to make one personal observation. I think I can expand that to all delegates from Scandinavia, that we are very pleased about the widespread use of air conditioning here in Hong Kong. Okay, let's give another round of applause, please.